Hello and welcome to Mark of the Web, the continuation from our previous two videos on HTML smuggling and JavaScript obfuscation. Now, in the previous video, we discussed the concepts behind JavaScript obfuscation as well as HTML smuggling and how the obfuscation of our source code can make both our payloads more resistant to defensive solutions as well as analysts. However, there is another obstacle we have to take into consideration when payloads are delivered over the internet, and this obstacle is called Mark of the Web. This video will mostly be theoretical and its evasion strategies will be discussed in the following videos. And as per usual, everything we teach in this video is purely for educational purposes. We take no responsibility for your actions. So what is Mark of the Web? Well, simply put, Mark of the Web is a metadata identifier that marks files downloaded from the internet as potentially unsafe. Essentially, any file that you download from the internet will be appended some properties that will signal to the Windows operating system to perform some extra scrutiny over the file and signal it to the user. Now, you may wonder, how is this all applied? It is done so through the use of alternate data streams, an NTFS specific feature. It applies a hidden secondary stream of identification data besides the primary data stream, the stream that contains the data of the file. So whenever the Windows system performs its analysis over the file, should it need to, it will attempt to look at this secondary stream and take the best judgment on whether it should be executed depending on where the file originates from. Now, Mark of the Web is highly prevalent and it's applied by almost every modern web browser today. As such, the capability of removing Mark of the Web falls outside our hands. There are methods of evasion which we'll discuss shortly. However, to understand this concept a little better, let's take a look at how Mark of the Web is applied practically. Now, in our previous two last video, we discussed HTML smuggling and we developed a payload that is capable of serving an additional payload through the use of JavaScript blobs. And we are using this payload here to serve an additional payload. So if I refresh the page, you should see that the payload should initially start its download. Now, in the case of Internet Explorer, it will temporarily pause the download due to Microsoft Defender Smart Screen. Now, there are many reasons for why this download may pause. One of them being that it is originating from a web server without a HTTPS certificate, and also Microsoft Defender may not recognize that executable as being legitimate. So if we actually select more actions here, we'll simply select keep, and then you'll see a clearer message for why the download was paused. Now, this is important because this is the first obstacle that a user is bound to encounter. Now, we can bypass this limitation by sending any other file that is not an exe, but that is for a separate video. Now, before we attempt to run this downloaded file, if we right click on the executable, select properties here, you'll see a security attribute has been applied to it. And this security attribute is essentially Mark of the Web. Now, if we actually attempt to execute it this way, so double clicking on it, you'll see that Microsoft Defender Smart Screen prevented the executable from running. And again, this is due to Mark of the Web being applied to our file. Now, because this executable originated from the internet, from a remote web server that might be anywhere in the world, some Mark of the Web identifier information was applied as a secondary stream to the file, and thus Microsoft Defender was capable of determining that this file is potentially malicious. And keep in mind that at this point, our executable was not even running. Now, we could instruct the user at this point to simply select more info here and select run anyway, but there is a restriction for blue teamers to actually enable that this only happens from administrative accounts. So if a user does not have access to an administrative account, they would not be able to run it. Anyway, I suggest that you do some research on this in your own time. Now, let's actually right click on it again, select properties here, and I'm just going to select unblock. Now, this should remove the Mark of the Web identifier information that was applied to the file, and it should prevent Microsoft Defender Smart Screen from inspecting it any further. So if we select apply, okay, and run the file again, given some time here, you should see that no other Smart Screen prompt is raised. And if we actually go into Task Manager here, and attempt to locate this file, there we go, you can see that it has successfully executed and is running as a process. Now, remember I said that a secondary stream is applied to the downloaded file. Now, if we use get child item here, we'll see that no other stream than its primary data stream is present. Now, the secondary data stream or the data stream that contains Mark of the Web will be hidden, and to actually view it, we'll have to use get item, specify a path here to our executable, and then use the stream switch. Now, the stream switch accepts an asterisk but we can actually specify Zone.Identifier to view the secondary data stream. And once again, this is the data stream that is applying mark of the web. Now, simply by using getItem, we won't actually be able to inspect this secondary data stream. Instead, we will have to use getContent. We'll have to specify the path to our executable one more time, and then stream Zone.Identifier. And then you should see the mark of the web information present. Now, these two attributes, referrer URL and host URL, are quite important when it comes to forensics, because say a system is compromised, you can then view the alternate data streams to potentially inspect where the file originated from. So as you can see here, mark of the web applied a referrer URL attribute and a host URL attribute, which essentially identifies the originating server. Now, from the perspective of how much scrutiny is applied over the downloaded files, it is stored in the ZoneId attribute. And this attribute contains a level value from 0 to 4 that identifies a file zone of origin. Now remember, I said there are varying levels of how mark of the web is applied. And this is determined by the ZoneId attribute that is held within the ZoneIdentifier stream. Now, most of the time, content that we serve on remote web servers will be applied an identifier value of 3, which signifies that it has been downloaded over the internet. However, there are 4 more identifiers we should be aware of. A ZoneId value of 0 indicates that the content resides on a local computer. And this type of content is trusted, and therefore Smart Screen is not prompted and is treated with a high level of trust. A ZoneId with a value of 1 refers to content residing within an organization's intranet, such as local web servers. Now, because these web servers are within an organization's firewall, it has a higher level of trust than the content served over the internet. A ZoneId with a value of 2 refers to the content that originates from websites that have been deemed reputable. So these are the websites that the user trusts. And keep in mind that these websites are manually added by the end user. Lastly, a ZoneId with a value of 4 is the most comprehensive option for mark of the web and will signify content originating from websites that are identified as potentially harmful. And once again, these websites are manually added by the end user. Now, I will repeat this once again. There is no way to actually manually remove the zone identifier information, and instead we have to perform some bypass techniques. Now, there are several techniques in which we can bypass mark of the web, with the most common one being exploiting file extensions that do not have support for mark of the web. Now, because mark of the web is an NTFS specific feature, some file types may not support appending it. For instance, container formats such as ISO do not support NTFS and thus may not apply it for the contents inside of it. Now, there is a caveat to this, which we'll see in the next video, but it is still useful today. Another common way in which this can be evaded is through utilities such as 7-zip. Those utilities have been previously proven to suffer from vulnerabilities that enable the evasion of mark of the web. A prime example is CVE 2025-0411, a flaw within the handling of archived files. When extracting files from a crafted archive that bears mark of the web, 7-zip will not propagate mark of the web to the extracted files. Now, of course, this requires that the victim is affected by the vulnerability, which most of the time we will not know or know whether 7-zip is the extraction utility. However, it is still an effective method. Lastly, modern phishing techniques such as FileFix also enable mark of the web evasion through carefully crafted instructions for the user to perform. Now, because of the sequence of steps that are instructed for the user, mark of the web is either stripped automatically or the user is instructed to do so manually. Okay, so the final few videos will focus on the last few phishing techniques, where we actually deliver payloads to the victim in order to establish an implant session within the system. We will use several techniques that are not only effective ways to launch an implant, but are also effective at bypassing mark of the web, which we will inevitably encounter. That said, I hope you enjoyed this video. If you did, please drop a like as it helps us grow. Additionally, feel free to join our Discord server, for which a link to I've left down in the description below. There you can reach out to us, chat, contribute, and soon participate in an entirely Discord-based virtualized lab instances. Until then, stay safe and keep learning. See you later.